this video is on shop floor planning, same topic as has been already put on my channel. This time around it's just another row. It's under job minimization time. How do you minimize job time? So you'll see as we will handle this in this question, there's a certain rule, Johnson rule, that we'll be following here. So the question says the times required to complete each of the 8 jobs in a 2-machine flow shop are shown in the table that follows. Each job must follow the same sequence, beginning with machine A and moving to machine B. A. Determine a sequence that will minimize make span time. Determine a sequence. So how do you determine a sequence using that will minimize? So as I said, the keyword there is minimization. You're going to minimize the time of a job. So here there's a rule that works. It's Johnson rule whenever you're trying to minimize the time of the jobs you're sequencing, and I'm going to show it the next screen as we solve it. So the Johnson rule has got some steps. So before we start, I can just help you highlight some steps. So Johnson rule says that you have to first identify job having the least time. So identify job with least time. That's your first thing that you're looking at. And this job, once you identify the job with the least time, the next point is that check if it's in the first machine. If it is in first machine, if it's in the first machine, what will happen? Okay, maybe that point I've stressed. What will happen if it's in the first machine? If it's in the first machine, do the job first. Do job first if in first machine. That's the point. First machine. Just be abbreviating these things. Yeah. So that's the first. That's the rule there. If it's in the job having the least time falls in the first machine, then you do the job first. Then if the opposite occurs, let's say it's in the second machine, then do the job last. But it still has the least time. So you know the criteria first. That's why I said the first thing in Johnson is that identify the job with the least time. That's the first step. Then next, check for which machine is it in. Is it in the first machine or is it in the second machine? That's what you look out for. Yeah, so basically that's what you're checking, that if it's in the second machine, do the job last. So the thing is this, you're going to, what do I mean by first and second? Let's say I've given you A and B, like in our question. The first machine is A, the second machine will be B. That's how you know. They will say, sometimes they'll say machine 1, machine 2. The first one is machine 1, machine 2, just like that. That's the order. If it's alphabetical, we follow alphabetical order. So basically this is the rule. And then they say once you identify the job, you find the job the least time, you even treat it in the rules whether it will start last or it will begin, then repeat the process again. Which job is now the least after that one has gone, you've gotten rid of that one, which one is now the least amongst the remaining figures. Just like the rule keeps repeating itself. That's what happens. So let's do it according to this question. So remember that we had A, which had 16 in machine A and 5 in machine B. Then we had also job B, which had 313. We had job C, which had 96. D had 87. E had 214. F 12 and 4. G had what? 18, 14. And finally H had what? 20 and 11. Then you start, which job has got the least time amongst these shown here? Mind you, machine A is here. This is machine A. This is machine B. Yeah, then we plot them. This one, you find that E, this one, it has the least time. Which machine is it in? This number 2. 2 is in machine A. The figure 2 is in machine A. And apparently that's the least figure we're seeing in the whole chart. It's 2, that's the least figure, and it belongs to which one? It belongs to E. Therefore E will be the first job to be done. That's how you follow the Johnson's rule. If it's in the first machine, you do the job first. Then to make your life easier, make sure you cancel a job once you're done to avoid what? Repeating it or putting it back into the selection, that's what we're trying to avoid. You look at the next one. The remaining ones, the rule repeats itself. Which one is the least number among the remaining ones here now? Take note that after 2 has gone, we have a 3. There's a 3 up there. Job B there here. Again, which machine is that number 3 falling into? It's in A. Therefore, job B will be just done after E, because the fact that E started first, if there will be another job that drops in the first machine, to just follow through, but the rule is that they should be in the beginning. That's the whole point, if it's in the first machine. So since E already took the first position, B cannot also take the first position. If you get what I mean, it will just follow. Yes, apparently it's also in the first machine, but it will just keep following. That's how the sequence will go. Get rid of B. It has gone. Which one is the next least number, or the least number among the remaining ones? It's 4. 4 is in which machine? 4 is in B. So here, be careful. 4 is in B, and it belongs to which one? F. It belongs to F. So the rule says that if the least number falls in the second machine, do the job what? Last. So I know somewhere I'll come and put F as the last job. Or among all these, it should just be the last job. That's just the rule. And then that's it. You can get rid of F. Among the remaining ones, which is the least number, there's a 5 on top belonging to A. Okay, it's in machine B again. It's 5. What's the rule? Do the job last. Now, how do you categorize it? Remember, F has already taken the last position. They cannot fight for the position and say, okay, even A should be last. No. Since it has come after F, it will just be second last. It will still be at the end, but second last, not last, because F came first in terms of taking the last position. That's why you do that. Even do that. Next, you get rid of A. They're reducing. 6 is the other least number among the remaining ones. Job what? Job C. Even put it here. Again, it cannot move A and F since it has come after this. It will just be the third last job. But mostly, just remember that it's supposed to be put at the end, because it was in the second machine. It cannot be in amongst the beginning jobs there. The next one, once C goes, you have remaining with a 7 there. 7 belonging to job D. Yeah, if you check job D, there's a 7 again, it's in machine B. Therefore, again, you put D here. Just like that. Then D, get rid of it. We have G and F left. We have 11. Okay. Yeah, we have 11. We have a 14. This is 14, by the way. We have 20 and 18. The least number is 11. Which job? H. You can put H here. It's in machine 2. So again, to just be behind D there, coming from behind, that's how it will be, that one. What about once H goes? You are remaining with which one? G. So once H goes, we're remaining with G. And apparently G has also got a figure in the second machine, and apparently it's our last job. So basically, this is our sequence. E, B, G, H, D, C, A, F. That's the sequence. So basically, that's the sequence they wanted you to come and determine in that order. Okay, you start with E, B, G, H, then D, C, A, F. So if the rules, you might be struggling to get the rules, I would advise you just repeat the video and have a look at how we have obeyed the rules of Johnson rule. And basically, this is how you sequence the first part of the question. So you've now made the sequences. It's now a matter of answering the next part of the question, which I want us to tend to. The next part of the question is mentioning construct a chart of the representing sequence and find idle time for each machine. So it's an approach that you can actually answer this to find idle time. You create a table. In fact, it's even much easier to answer this part B. So this chart, we're going to say, okay, it's a table in our case. What you can do is that you can have machine A, machine B, then on each machine put columns for in and out. In and out for both of them. In, out. Okay, from there then we start putting the jobs. So we start with E in the order of the sequence. That's how you're supposed to put them here now. In the order of the sequence you have determined. That's why the sequence, if it's wrong, you fail this part also. So make sure the sequence, you are very careful with it. Yeah. E is the first job according to the sequence. You start with the one in the beginning. So E, what would be the in? What do they mean by in? The time the job will start. So since E is the first job, it's starting from the initial point of where it's 0. That's how you should know. Then what time does it come out? Remember, each job has got a time that it's taking. That's what you look at, because that's the duration of the job will show you what time it can come out by just saying this. We just follow this model: in plus duration, huh? Then that's it. Then that's how you determine your what, your out time, basically. So let's answer the question. So once you put in your in and out, you're going to say E had 2 minutes. If you recall in our question or rewind, it had 2 minutes E as the time it was spent in A. That's what they said in the question. So you say that 0 plus 2, just 2. It comes out at 2. Then what about this side? Because remember, a job has to go through both machines. That's how the sequence is. So they told us already that there are 2 machines, A and B, and the jobs, of course, have to be processed through those 2. So once E leaves machine A, it has to go to B. That's the rule. It's left A, it goes to B. What time does it enter B? Under normal circumstances, you cannot start at 0 because B is the second machine. Therefore, you start at the time it came out in A, that is at 2. Then what time does it now come out this side at B? The duration that E is spending in B is 14. So what is the formula again? In plus out to give you what? Sorry, in plus duration will give you the out time. So 2 plus 14, 16. After that, we just the next job, job B. Go to job B. Job B will start at what time in A? Because remember, machine A is a starting job, not starting machine, of course, for any job. So B is now coming through. Since E, they've produced it, they're done. B will start at 2. Why is it starting at 2? Remember that in A, as it's entering A was free at 2 minutes. So therefore, the next job that can come through can join in at 2. At point 2, because time cannot be reversed. Huh? It's already gone. 2 minutes have gone by. You cannot say, oh, let's start from 0 again. So 2 plus, that's the duration for B in machine A. They've told us in the question that B's duration in machine A is just 3. So 2 plus 3, it comes out at 5. It goes to where? It goes to machine B as the finishing point. Now, can it enter at 5 like the way we did for E? That since it came out at 2, you also enter at 2. Even this one, since it has come out at 5, you also enter at 5. No. Look at machine B is only free after 16 minutes have gone by, or hours there. So what you're going to do is that since it came out at 16, since B is free at 16, machine B is free at 16. Therefore, only job B can only be accepted at 16 to enter. That's how you interpret these things. Just follow the sequence of the times and it will help you. So B is spending 13 minutes here in B. Therefore, 16 plus 13, 29. That's the time it comes out that side. You got the next job, job G. Job G, what time does it enter in A? A specifically. A was free at 5 minutes. Therefore, G will start at 5 minutes. What's the duration of G? In the question, they told us that it spends 18 minutes in machine A. Therefore, 18 plus 5 is 23. Once it comes out, G is supposed to go to machine B. Machine B is free at 29. So same story. We couldn't say that just because G came out at 23, it should start at 23. No, is the machine it's going to free also. That's how we always determine this. So the machine is free at 29. Therefore, it enters at 29. And you add on. What are we adding on? That's G. We're going to add a 14 because it's spending 14 minutes in machine B. So when you add 14 plus 29, 43. From there, you go to the next job, job H. On the fourth job now. Job H spending how many minutes? 20 in A. So first of all, it enters at 23 because machine A was it was free at 23 there. And then once it was free at 23, the job will spend 20 minutes here. It comes out at 43. 43, it's free. Therefore, they're actually free at the same time. These machines you've seen, this one is free at 43, this one has come out at 43. Therefore, it will even enter at the same time 43, since they've just matched. Just so happened. Then it's spending 11 minutes here. Therefore, it comes out at 54. Remember, the table continues. We're just going to go to the next. We're just going to erase this just for the sake of our space here on the screen. But the table continues, by the way. So let's move on. We still have machine A, machine B, in out for both, in out times in out. So what's the next job after H? It's D, Job D is remember A, if you rewind from the video, A was free at 43. After I just did H, it was free at 43 minutes. So you start from 43, this job D. What's the duration? It's 8 minutes, therefore it will come out at 51. This side as well, this machine was free at 54. That's when it was finishing H. This machine B, it was finishing H at 54. So yes, this one has come out at 51 an earlier time, but it can't start at 51 until the other one is free. So therefore it will enter at 54 when then B is done with H. Then what's the duration? This side 7, therefore 61. It comes out at 61. The next part is the next job is C. Job C. Job C enters at what time? In A, job C will enter at 51 because that's when machine A was free. Then it's spending 9 minutes. This is 60 here. What time does it enter B? At 61, due to the fact that this is when B was free. 61 plus 6 as the duration for C and B, 6 minutes, so 67 comes out. Go to the next job A. Job A will enter at 60 because starting from machine A, which was free at 60, plus 16, 76. That's the duration it would spend 16 there, that's 76. Go to B. What time does it enter B? Yes, B was free at 67. You would say, why can't it also just start at 67? But the thing is that it was only done until 76. Therefore, it can only start at 76. That's what happens because that's when it was free. That's when you can start this other side. So 76 plus what's the duration of A? In machine B, it's 5 minutes, so 81. The last job is F. Job F enters at 76 in machine A. The duration of F is 12. Therefore, we have 88. Comes out at 88. What time does it join machine B? Machine B is free at 81, but the fact that this one came out at 88 to start at 88 here. Duration is just 4 for job F. Therefore, 92 is the final time in all the processes. So the overall time there it's 92 and we are done with the table. Now let me show you how you can handle the overtime part. What you would notice is this. I'll start from the bottom going to the top. I'll even rewrite the table that we initially erased so that you can tell overtime. They said overtime for both machines. So overtime is just this. Let's start with machine B. A is the simplest. I'll just show you at the end. Let's start with B. B, what you're going to do is that take note of the times when B waited. Just what B waited, and you'll notice I was even saying that okay, B here was done earlier, but A wasn't done. Those are the areas we're focusing on. Look at where job B, machine B, this machine B, where it was doing job C. Look at the fact that it had finished at 67. But it waited for job A, the next job, at 76. So that time B was just waiting. That's idle time. It finished at 67. It was waiting for its next job. But the thing is that the next job couldn't come until 76. Therefore, you can say we have idle time of 9. Even record it somewhere. Just put separate that okay 9. One of the idle times identified. Take note about another point when it waited. Look at here. Job here B was done at 81. Okay, here it was done at 81, but it waited for F, its next job, at 88. Therefore that's also idle time. Therefore you say 7. Take note of it. There's another point where this machine waited here at the beginning when it was doing job E. Remember job E when it started, it was something like this. That's okay, sorry, that's in out. Remember job E started like this. It was like this in the intro when we started everything. Here it's like 16. So when B was waiting for E to be done this side, it started at 2. It did not start from 0, meaning it waited. That's also waiting already in its case. Even though it's at the beginning, that's the fact that it couldn't start at 0. Then it was waiting. That's how you determine. Therefore, this is another figure where B also waited. So yeah, in the other scenarios you'll notice that B wasn't actually waiting. If you rewind the video, this is the only point in time when B was actually waiting. At the beginning and at the end, on the part where I've already demonstrated, the other point in time A was finishing way earlier, and it was basically not the one. B wasn't waiting at that point. Now they say to easily get the time that will be the idle time for machine A. Remember, The final total was 88. In the column for A, it was 88 in the out time. While the out time this side for machine B was 92. So they just say calculate, just subtract the difference of the final out time of both machines, then you'll know that that will be the idle time for A. That's how you do it basically for A. So that's just the criteria that works there, and that's your Johnson rule and the idle time calculation. So therefore for B to be 9 plus 7 plus 2, giving you 18 as the idle time for machine B. And that's it on the Johnson rule video.